Good afternoon to everyone. My name is George Potamos, member of the Cybersecurity and Telecommunications Research Lab of the Open University of Cyprus. And I will present you today our proposal how to build maritime cybersecurity capacity against ransomware attacks. Slide, please. During the presentation, I will explain how ransomware is considered as a maritime threat in the maritime context. Through the recent incidents, the profile of the threat will be analyzed, providing the required aspects for educating and training maritime stakeholders across all the roles and responsibilities. Attack methodology is part of the analysis, explaining the difference when an attack is deployed on board instead of ashore. Practical part with a scenario demonstration, which is part of the curriculum, promotes active learning and make education memorable and actionable. Practical lab will, of course, be an item for the today's presentation. Slide, please. In recent years, cyber criminals have shifted their attention to critical infrastructure organizations, deploying a quadruple extortion scheme to maximize their profits. The scheme involves deploying a ransomware and encrypting the organization's files as a single extortion, exfiltrating sensitive data and threatening to publicize them, double extortion, further disrupting operations with a distributed denial of service, third extortion, and finally, establishing recent communication with customers and supply chain shareholders to force the organization to act upon the cyber criminals' demands. A critical infrastructure as target of adversarial campaigns involves the maritime domain, like ports, energy transportation units, storage facilities, shipyards. In addition, ransomware exists as threat for ships, especially if the attack infects the critical parts of the ship, like navigational systems, in our case, the management system ECTIS, and cargo machinery management systems, and of course, shipping companies. Next slide. Since 2010, major cybersecurity incidents occurred in the maritime domain, and especially against shipping campaigns and port servers, causing enormous financial impact. 41% of the reported incidents were relevant to ransomware attacks. Additional to the known incidents presented statistics, several scenarios were constructed to demonstrate the possible implementation of ransomware attacks against maritime OT systems, like disruption of the ECTIS, as mentioned before, during the sailing of the ship, take control of crucial peripheral systems, such as cargo management and onboard machinery management system, and block navigation systems, and force the ship to sail without electronic plotter assistance. Next slide, please. So to demonstrate the problem, valuable observations are extracted by the recent incidents as follows. Ransomware impacted both onboard and ashore maritime stakeholders and assets, like all types of ships, cargo, tanker, cruise ships, and others, and shipping companies, energy critical infrastructure, ports, and other maritime infrastructures. Both IT and OT systems may be infected. Several ransomwares impacted using different initiated access techniques. The attackers managed to cause huge financial consequences using ransomware, and the attacker's motivation is beyond getting ransom, focusing on the disruption of services, affecting the supply chain also. According to the mentioned reasons, the proposal aims to empower stakeholders to effectively and efficiently address a ransomware attack. For this purpose, situational aware training may serve as tool to build maritime cybersecurity capacity. Slide, please. As shown in this slide, tactics and techniques from the MITRE ATT&CK framework can be utilized to apply a ransomware attack in the maritime domain. Initially, to facilitate the selection of adversarial tactics and techniques, the existing vulnerabilities of the maritime IT and OT systems have been used. Moreover, it was taken into consideration that the maritime domain includes ships and offshore maritime infrastructure that have different IT and OT systems and different operational perspectives and operational capabilities. As presented, a range of techniques related to ransomware attacks have been identified, indicating which of the techniques can be applied against the ship or offshore systems. Both of them are illustrated in the slide. In addition, it's shown that most of the techniques may impact the IT systems of the ship, including part of the OT systems. In such a case, a ransomware attack may have operations impact on the ship, changing her maneuvering behavior and capability. In the context of creating training exercises, the scheme can be utilized to guide the design of specific attack scenarios, demonstrating specific adversarial capabilities that target to infect specific maritime assets. Slide. This slide presents the key cyber aspects and design directions for the development of future curricula, includes the analysis of the audience and the scope of the training, the specification of the learning objectives, and the development of learning content to support these objectives. A key element to consider is the pedagogy utilized to deliver the learning content and activities, especially in order to complete the learning content and be effective with it. Next slide, please. Now for the scope of the audience decision, the challenging part is to determine the capabilities that people need to develop across the different levels so they can handle a ransomware incident. In particular, at the strategic level, senior decision makers need to build knowledge and skills to handle ransomware from a business perspective. At the operational level, people that make day-to-day decisions regarding maritime operations should build capabilities to address ransomware incidents that affect operational aspects. And at the tactical level, personnel must be able to identify adversaries, actions, and the assets that they have been compromised to inform and drive tactical decisions. Such an approach can assist all parties involved to understand their role in mitigating ransomware incidents, building relevant knowledge and skills on an individual level and on a team's level. Slide, please. At this slide, the key learning objectives across a strategic, operational, and technical level are presented. The proposed learning objectives is not meant to be exhaustive, but indicative and can be further elaborated depending on the training needs, the personnel's roles, and the proficiency level of cybersecurity capabilities that need to be demonstrated by the personnel. Slide, please. As mentioned before, for the support of the training objectives, a key element to consider is the pedagogy, utilized to deliver the learning content and activities. Active learning should be pursued to improve cybersecurity awareness and training levels and build practical skills. As we can see in the schema, active learning is empowered through kinesthetic learning. This aspect can be supported with the use of Maritime Cybersecurity, delivering demonstrations and practical activities. This is taken into consideration when designing the proposed curriculum, indicating the topics where practical activities can have a fit. To promote the learning objectives, 4 thematic areas have been considered, covering fundamentals on maritime domain and ransomware to assist attendees to understand how ransomware works and identify signs of infections as learning content 1 and 2. We will see them in the next slide. Ransomware cases, please go back. Ransomware cases in the maritime domain to gain an understanding of what the attack entails and the impact it can have in the maritime domain. Ransomware mitigation steps to be able to minimize the risk of getting infected, but also to get ready to recover if impacted by an attack. And then coordination activities, decision-making and communication during an attack in the context of a ransomware incident response plan to empower stakeholders to effectively and efficiently address the attack. So going to the next slide, the key learning content that deploys the proposed curriculum can deliver parts of the learning content to different audiences depending on the role and background as technical versus non-technical, while certain parts can be applicable to all maritime stakeholders working at a strategic, operational, and tactical level. Therefore, the curriculum developers should elaborate content to the appropriate level, considering the relevant audience. For this purpose, lectures, critical discussions, case study analysis, demonstrations, small group activities, tabletop exercises, audiovisual, and practical activities shall be used as different levels of the learning content. Slide, please. So a training environment is proposed as part of the Maritime Cyber range we have developed in our research lab called MARTE, in order to execute offensive and defensive drills, including training exercises related to ransomware attacks. As depicted in the slide, the platform contains the typical command and control systems on a ship or in an Azure maritime infrastructure. In addition, the adversary can implement a ransomware extortion scheme against maritime OT and IT systems on a ship, including navigation and surveillance component. You can see them in the right, upper right part of the slide. Industrial ICS OT systems on a ship or against maritime infrastructure, included in ports, shipping companies, operational centers, shipyards, energy transportation infrastructures, etc. IT systems utilized for administration and entertainment purposes, and also command and control like maritime situational awareness systems of a national maritime infrastructure capable to collect navigation and surveillance data from a ship or a fleet of ships. The high-level architecture presents the several systems and the existing networks connection for the several IT and OT systems. The ransomware attack point is also presented with the capability to run scenarios where the attack can be moved from the ship to shore and the opposite. Slide, please. Now let's see together an example of the training scenario. Initially, it's assumed that the attacker managed to compromise the VSAT communication system due to weak authentication measure and has access to the ship's gateway. Then, via network sniffing, the attacker can discover the connections and the data flow between the sensors and the command and control system. In our case, the Actis workstation as the critical part for navigation and composition of this situational awareness. This technique is feasible if the attacker monitors all the maritime protocols transmitted by the surveillance and navigation sensors as the relevant traffic from GNSS and metadata, radar and metadata, and AIS and metadata, communicated in plain text and collected by the specific command and control system. Once the active workstation is identified, a vulnerability is exploited to gain access on it because actually it's working as a service in a common operating system, and then modify its configuration file to run active as a service and establish a persistent connection. Establishing a persistent connection will allow the attacker to investigate more vulnerabilities and move lateral across the breach systems. Finally, the remote execution of the malware impacts the track streaming services, encoding the active directory and stopping the service. Due to the encryption, the attacker could impact the operational capability of the system and cause loss of control and loss of operational capabilities. Slide, please. As a summary, to effectively manage the risk of ransomware, all maritime stakeholders need to understand the risk and their role in protecting their assets they are dealing with. This can be achieved through cybersecurity awareness and training sessions. Engaging all stakeholders from C-suite and users to IT and technical personnel is critical to develop the necessary capabilities to defend, recover, and respond when faced with a ransomware incident. Sub-ranges can play a key role in promoting structured learning and supporting the use of different pedagogies to engage participants and achieve effective learning. The proposed new training curricula aims to develop specific cybersecurity competencies and provide design directions to build activities over the maritime cyber and develop capabilities to defend against ransomware attacks. This is the end of my presentation. I'm glad to answer any question.